Hi folks, this video is all about practicing solving exponential equations. So there are going to be six equations in this video, and I want you to take the time to try to do it by yourself. And then I'm going to go over the answers. The answers are behind these blue boxes, so I'll just remove those. So if you want to go ahead and try the first one, I'll give you about 5 seconds to hit pause, and then we'll show you the answer. So I think that's been about enough time. So let's reveal our answer for number one. And here is my work. Final answer being 1.431. In step number one, I apply a logarithm to both sides. I just choose the common log. In this case, it's helpful because I get log base 10 of 10. And anytime you get a logarithm with a base and the argument does the same thing, that equals 1. So that simplifies our equation a little bit. Although you could have solved this using the natural logarithm as well. So after applying the common log, then I apply the power rule to move the exponent out in front of the logarithm. And I want to solve for x, then I have to get x by itself. So I divide both sides by log 5, and then I evaluate this in my calculator. Let's give our second equation a try. So I've revealed my answer for the second one. And step number one remains the same. I apply the logarithm to both sides. Step number two is the same as well. I want to apply any log theorems. So the power rule is the only one that applies here. So this exponent gets written out in front. And it's pretty important that we put the brackets around here because the log 3 multiplies that whole thing and not just the 1. To get x by itself, I want to divide both sides by log 3. And then I have to subtract 1 from both sides. So I get a final answer of 1.579. I should note that I've rounded all of my answers to 3 decimal places. Here we have examples number 3 and 4. So give number 3 a whirl. So here is your answer. Again, step number one is apply a logarithm to both sides. Step number two, once again, is to apply the log theorems. Now in this case, there's actually 2 log theorems that I get to use. First one is the product rule. So I have 2 things multiplying each other in the argument, so I get to separate those as 2 logarithms with addition. And then the second log theorem is I have this power law, where the exponent needs to get written out in front of this logarithm. So after applying those log theorems, I need to try to get x by itself. So I need to move log 2 to the other side by subtraction, and then I need to divide log 3 to the other side, and then it's just evaluating in our calculator. So 0.834 should be your final answer rounded to 3 decimal places. Give the fourth one a try. So here's your answer for the fourth one. Once again, step number one, apply logarithms to both sides. Step number two, apply any log theorems. So I see I have a product here, so I'm going to separate the 2 and the 3 to the power x with addition as separate logs. And at the same time, I see I have an exponent here, so that exponent gets written out in front of the log 6. Please note that the x plus 1 is in brackets. On the left-hand side, I see I have an exponent again, so I'm going to use the power rule to write that x out in front. And then my next step, which we haven't had to do yet, is to collect all the x's together, or all the x terms. So this term has an x in it, this term has an x in it, so I have to move those to the same side, and anything without an x moves to the other side. So x log 3 stays on this side. X log 6, I have to subtract that to the other side. This log 2, I have to subtract it over to the other side, and this log 6 was already there. Then I'm going to factor out an x from all the terms on the side with the x's, so x log 3 minus log 6. And then to get x by itself, I have to divide this whole thing. So log 6 minus log 2 ends up getting divided by log 3 minus log 6. Punch it into your calculator, should get negative 1.585. And last but not least, we have 5 and 6. Try your hand at 5. So here's your answer for the fifth one. Same procedure, apply logarithms to both sides. Then I notice I have exponents in both arguments. So I use the power rule to write the exponents out in front. Then I want to collect all of the x terms on the same side. So I end up moving this x log 5 to the other side by subtraction. Then I want to factor out an x from both of these terms. So x log 3 minus log 5. And then I have to get x by itself. So I divide this to the other side. Now, I didn't even take out my calculator from this one because 0 divided by, and it doesn't really matter what's in the denominator as long as it's not a 0, the answer is going to be 0. You're welcome to use your calculator to verify this. Last but not least, we have number 6. And here is the rather lengthy answer for this one. Step number 1, as it has been all the way through this video, is to apply logarithms to both sides. Again, I'm choosing the common log for all of these. You could choose the natural log if you wanted to, but I just chose the common log. Step 2 is to apply any log theorems. So I have an exponent here, so I write that out in front, and I have an exponent here, so I write that out in front. Because this is a binomial, I put brackets around the x minus 2. Then I have another log rule that I can apply because I have a quotient in here. I can separate the 7 and the 3 with subtraction. So x is multiplying this whole thing as we separate it. And on the right-hand side, I distribute the log 5 through the bracket. So it's x log 5 minus 2 log 5. I kind of do two things in my next line. So I multiply the x through the brackets here. So x log 7 minus x log 3. And then I move this x term over to the other side as well. I do that through subtraction. By doing that, I have all the terms with an x on the same side. Then I factor an x out of all of these terms. So divide out an x leaves me with log 7 minus log 3 minus log 5. And then to get x by itself, I have to divide this whole piece here onto the other side. So negative 2 log 5 divided by, and then this whole piece in the denominator, log 7 minus log 3 minus log 5. Punch that into your calculator and you get 4.223.